Welcome, dear ladies and gentlemen, for another episode of Mr. Ballmer's YouTube video. Yes, and this time I'm showing you again some very interesting stuff. And what it's all about. It's about quantum computing. Here you see my dashboard of the D-Wave Leap directly connected to the cloud server from D-Wave, and this is the remaining QPU time this month, or actually till June the 17th of 2019, which I got 1 minute. Now I still have 58 seconds and 725 milliseconds left, and 3,915 experiment out of 4,000. So that means I run already some experiments. Actually, to be clear, I run already 85 experiments on the D-Wave quantum computer, the D-Wave 2000Q, which can be seen here. I run it on this quantum computer from D-Wave. That's the D-Wave 2000Q lower noise system. Okay, but I can switch. By the way, the lower noise version has 2030 qubits. This is the temperature, minus temperature. Actually, it's in millikelvin. The average time to wait before your code, your computer or quantum code is actually processed, or your code is processed, is between 1 and 10 seconds, and the status of the quantum computer is online. It should be online 24/7. It should, yeah. Okay, so the quantum processing unit, may I say that right? So I run already some experiments, as you can see here, since the 18th or May the 18th 2019. So let's go back. Those are my experiments which I run, and yeah, I'm going to show you how I run experiments on the D-Wave quantum computer in a second, okay? So I hope you are getting ready for this interesting experiment. So this, I opened the prompt, the command prompt, which is actually CMD. You can just put it in by, actually you press with the Windows logo and R, and then type in CMD, press enter on your keyboard, or click OK. And then yeah, this window will appear here, and I set it to a specific folder environment. So yeah, you can see I'm running Windows version 10, Microsoft Windows version 10, 64-bit German version. So okay, I will show you how it's done. Let's access the D-Wave, and I put in help that I show you step by step how you can set it up, or not set it up, how you can actually go once you already set it up. Okay, so type in D-Wave space double dash help, enter. So use the D-Wave options, D-Wave Cloud Client Integration Configuration Tool. So I'm going forward, I'm using the sample. So I write in here, I write here D-Wave sample double dash help again. Help. So D-Wave space sample space double dash help. Alright, and I got further on help information. Submit Sing dash formulated problem and return sample. So that's how I could then set it up. I already set it up, so I just implemented it. It's the D-Wave system, D-Wave sample, which is here. Then what kind of parameters? I used coupling text. I put in 1000, for example, which actually is already quite high, those numbers. You actually just go with 1 or 2 or maybe 5 or 10. That would be already, because this one, the n, is the number read integer, number of read sample. This is extremely high, so I don't need to repeat it by the integer of 1000. This is huge, okay? This is huge already in some way, but it's not really huge for a quantum computer. Yeah, it should not be. Okay, but I will show you. Usually you put in here 1 or 2. That would be already enough. So, well, let me try that. I will show you how it is done with 1 or 2. Well, let's say 1000. Let's go with the shorter version first, okay? Instead of 1000, I put in here 1 and 1, okay? By the way, V is verbose, increase output verbosity. Okay, then I go with the R. That's the random problem. Submit a valid random problem using all qubits. So I'm using, because I set it up, well, before that I will show you. Okay, let's ping the D-Wave quantum computer first. That means D-Wave ping. See, it pinged the quantum server. I'm using the solver as I showed you here. That's the solver. And that's the D-Wave 2000Q lower noise system. So I'm using this. I already put it in. So problem ID. Submit problem ID. So wall clock time, solver definition fetch, milliseconds, huh? Problem submit and results fetch, milliseconds total. Yeah, because the last one I submitted was a huge one with many integers, and it took some time. I will show you that again, and it will fulfill and give a lot of integers or numbers back, or results back, print results. So I'm just showing you how it's done in some way. There are other things which I will probably explain you later. How to access a quantum computer from D-Wave for actually sending a quantum code, a code to the quantum server. This is not a joke. We have the 23rd of May 2019. It's Thursday, the 23rd of May 2019, and this is real, huh? You can access a quantum computer. It depends in which country you are. I think in Canada, America, and I'm accessing the D-Wave quantum computer here from Switzerland. And I think in Europe you can also, and it will be extended to other countries on this planet, to other nations, to other countries as well, coming this year, by till the end of this year, 2019. So, and let me show you. So you see the quantum processing unit time, total real time, and so on and so on and so on and so on. And you can see this is extreme how they process the information. Okay, so, but yeah, I expect extremely much more to come. Hopefully, yes. Now it will. This is the internet is the medium of the 21st century. We all know this. And there are projects going on that will show you, or actually will enable you to have access, internet access from satellites wherever you are. So just to mention for a short in this video also, from SpaceX, they are planning Starlink, which at least, or by at least 2027, maybe even earlier, have a worldwide internet net with roughly 12,000 satellites flying around planet Earth, who will enable internet access, satellite internet access everywhere. And I just read that Amazon also planned to do something like this with a little bit less satellites, I think 3,000 satellites, that you have actually on the most part very high broadband, or actually internet access by 2025, or may even earlier. So there are a lot of things coming, and why I'm saying this, it's because I just read this information. I just read this information, and let's go back to the things which are coming and will be huge. Okay, this will change the world as we see it today. And this is on one side, or on the other side. This is, one of them is quantum computers, quantum computing. And the other one, or the second one, or the other one, first one or second one, the other one is artificial intelligence, short AI. Okay, those two things will fundamentally change how we see the world in different ways, or actually enabling us to discover more things, do more things, and do things we have not even imagined yet, which is, it will be extreme. Okay, I repeat for a short: quantum computers, quantum computing, and artificial intelligence, short form AI. These two things, okay, these two things will fundamentally change our world we know it by today in many different ways. So it would be also very interesting if, yeah, maybe considering investment. Ladies and gentlemen, technology is extremely advancing and and also very promising. So, okay, here we go. Well, let's go back to our accessing time. So, I could show you more, but in this video I will show you how code will be executed by the D-Wave quantum computer. Actually by this one, the lower noise version. So as you see, I set that already up here using the solver. This is using the endpoint. This is here, which you need to access the cloud. The D-Wave system that you can process the code and then changing it into quantum processing, quantum state, or quantum code, and then give me the result back, of course, because quantum state or quantum computing is fundamentally or different. We say it this way, but it's completely different, and it has it will be extreme, and it already is, but it's just the beginning. And of course you need your personal API token. This is my personal API token behind here. So I already put that in, so let's see it, how it works. Okay, I will show you that. Let me put that in again here, but a little bit shorter. Instead of 1000 I put in 1, and the n, the integer, also 1, because I only need 1, and then the verbosity and the random problem. Execution looks like this. I'm going to execute it a little bit. Let me make this full screen. Let me make this a bigger screen. Okay, when I hit enter now, it will be executed on the quantum computer. Okay, I counting down on 0. On 0 I'm doing it. Okay, 3, 2, 1, 0. Yeah, you see, that is like quantum code, or how do you want to call it? It's yeah. Let me scroll that here. Here, accessed the D-Wave cloud server, then using the solver, the quantum computer, and I'm going down. Yeah. Can you see if I'm here standing still? It looks like some kind of wave standing still, but if I'm moving, it's very different, right? So scrolling. It's odd. I show you. I'm not doing anything. It's just scrolling automatically here through, and yeah. But this is a very simple thing which I put in. Okay. Result variable. Variables format, number currency is 1, active variables, and look the shape and how it's done. My gosh, can you even understand this, right? The solution is provided as follow here, and it's this. This is like the solution which will give the calculation, and then the solution by calculated it. So let's go down. Total real time, quantum processing unit access, quantum processing unit access over heat time, the anneal time per run, 20, and all the kind of post processing overhead, and read time per unit. This is, everything is calculated in some way. So because I put in the verbosity, it shows me this. Otherwise it looks very different. And the occurrences is 1. This is the result. Well, I put in 1, 1. I put in 1. So obviously the result should be 1. Maybe 1 and 0 at the same time. Who knows? But yeah. So let's clear it up. CLS cleared. Okay, let's go back again, and we are almost there where we started. It's just a very short glimpse for you to see how a very simple program is executed on a D-Wave quantum computer. Okay? And the result showed me 1. I could put in many different codes, but this was just like some parameters in some way. Yeah? Very simple ones. 1 and 1. Just 1, right? So think about if I'm writing a program which has thousands of lines, or maybe tens of thousands or hundreds of thousands of lines. Think about if you're sending a Mars, a rover, like the NASA Mars rover, some of them, like Curiosity, okay? The execution which the program then took or made automatic sequence, it will be executed step by step with all the parameters, with all the measurements and all the data measurements and everything, till it's landed. Once it's entered the atmosphere and everything, it had, I think, 1 million lines or some few millions. I need to see that again, but it was huge lines of lines, and what I just did is not even write like a line, maybe 1, if you want to call it. This one here, I'll show you. Look, this one here, is that a line? Maybe, but if you have like this, that would be a line till here, okay? That would be not even a line, but it is a line, yeah, 1 line, okay, in some way, but it's not really a code. Maybe it is. But if you think you have tens of thousands, hundreds of thousands of lines here, yeah, and everything is like numbers and programs and codes, and everything needs to work perfectly. That is how you can execute some program completely automatically, or actually the program will be executed automatically and it should do its tasks perfectly, right? Think about it. Think about it. Think about it. And now I put in 1,000 and 1,000. Let's see how that looks. Okay, but before I'm showing you that when I actualize, it will be counted down. It's not 3,915. It will be counted down, and here it will be added. The time will go down. Let's see. Here we go. It's shorter. I have 1 experiment more done. Instead of 3,915, I have 3,914 now. And I have done that experiment. Can you see? Here we go. Okay, and yeah, I will show you again an experiment. I will go into full screen or big mode, if you want to say it like that, and I will execute this one. Remember before, I just add 1 and 1, and now 1,000. This is a factor of extreme more, right? It's the same thing, but instead of 1, it is 1,000, 1,000. Okay, let's see how that looks. I will count down on 0. I will press return and it will be executed. Are you ready? Have a look on this one. Counting down. 3, 2, 1, 0. It's now running. It's now running all the integers, finding the right parameter. It looks like just lines, but it's calculating. This is extreme. So it's finished. and now I go up, up. So it is, I cannot even go higher because, because it already started much higher, remember? I cannot go higher at the moment because it's probably already full of all what you can display here. Yeah. Okay, let's go down. Okay, have a look. You see on the right, on the far right, how the slider is going down slowly. And look at this. This is like code or something, yeah. Calculating all the possibilities, which is the best solution. Yeah. The slider is roughly about a third, a fourth or a third. Yeah, and it was much more in front, above. Yeah, remember that? But think about, you're riding this. Yeah, you're riding this. Excuse me for that you watch like this. Okay, you may. I'm just going through that you can see. These are all different parameters. Okay, I'm stopping here for a second. Yeah, because I slide it down for how many seconds, and I'm not even in the half. Yeah, and maybe above it was much more. So you can see calculating all minus 0, 0, 0. There is 1, and my gosh, and there are brackets and brackets and all the kind of stuff. As you can see, different combinations. So let's go a little bit further. Okay, a little bit faster, a little bit faster, 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 faster. I could scroll down like this, like this, for I don't know, 2, 3, 4, 5 minutes or so, maybe 1 or 2 minutes. So here we are. Occurrences 1111111. Energy used. Let's go a little bit further down. The energy who was used and so on, and yeah. And much more above, maybe even much higher above, there is much more, but it will not, it isn't showing me that because maybe it's so big. Yeah, just to show you, this is like how quantum computer, but this is just a very, very simple stuff which I show you here. Okay, it's a very simple stuff. It was just one short line of parameters, thousand and thousand. Think about if you have hundred thousands of codes. Think about this, yeah. But calculating was much faster. It was showing me different things, but just to show you, okay? So let's clear that, CLS, and we are almost there where we were before. See, here we go. And let's actualize it. Let's see what happened. Whoa, it used quite a lot, yeah? And time also. Yeah, well, milliseconds, but it took some time and it used some few experiments. So 14 plus 8 is how much? 22 experiments were used in this one. 22 experiments. 22, let's see. 22. Let's actualize this sometimes. It's 22. Completed. So how many experiments here in that experiment? That was one experiment, but it used many experiments, actually 22 experiments in that experiment in some way, right? So Yeah, that was quite big. How about I will change this parameter for a second. Let's say I'm using minus 1000. Let me say I'm going to 10,000 and then to minus 10. Integer minus 10, is that possible? Let's see. Oh, I forgot something very important. N minus 10 is 10 and minus R. Let's test that one. Okay. Oh, not N. Excuse me, V I should write here. My gosh. Okay, let's copy that one for a second. CTRL and C once it's selected, huh? Select and then CTRL and C. CTRL and C. So that's a V here. We need a V here. Minus V minus R. Execute. Here we go. Okay, that was much faster. Some number of samples. The number spin reveal transforms must be positive and not greater than numeric. Ah, positive. That's the point. Okay, must be positive. Okay, can't be negative. An integer must be. Okay, I understand. Let's do that again. Instead of, let's put in here sample 2. No, it's a quantum computer 10. Instead of minus, plus 10, then V and R. Execute. And here we go. Finish. That was much faster, huh? Occurrence only once. Okay. So yeah. CLS. And let's do something different. Let's put in different numbers here. I want 9,000. 9,999. Okay. Then again, what did we set here? The N was 10, huh? Let's go to 100. Why not? And V and R. And I'm going to bigger mode, executing at 0, counting down, 3, 2, 1, 0. Oh my gosh. Here we go. 0. It was there. That was the problem. It should be clear before you start. Here we go. And it's done. It's done. So let's see how that was. Let's go up. Here we go. Now I can see the full one. Okay, looks a little bit different. Let's stop here. Different numbers we got here. My gosh, look at this different numbers. That's amazing. Don't ask me what it is. But it finds the best solution. Oh my gosh. Yes. Yeah. We put in different numbers. Let me try that one. Let me try this. Oh my gosh. Can't. D-Wave sample. J was, how much was J? 9,099. Let me go with 99,999. Then the integer with, let me say, 2030, and verbosity. Let's not put in the verbosity for a moment. Let's just execute it with the random problem. Let's see how that goes. But before, I will copy it. Yeah, make it right, Mr. Palmer here. Okay, copy and execution. Let's see. See? When I don't put in the verbosity, it will show me just the necessary results. Okay, and it is counted here. So number of samples. And let me do that again with the verbosity. Okay. Hi, it was not copied. Wait, sample J 99,999. It was 2030. Then the verbosity and the random problem. Execution. Here we go. Have a look. All the parameters, and now calculating and the best solution. Finding. Yeah, that is quite huge, huh? That is quite huge when I put in 2030. But it's a quantum computer, come on. Yeah, it's calculating. This is let me go into full screen for just a second, okay? So you can see it's still calculating. Here we go, it's finished. How does it shows? Your currency is only zeros. Yahoo. Only ones, I mean. Yeah, it's huge. I cannot even show the full ones. Okay. So CLS cleared. So let's go and see how much I used for that, all the kind of things. Oh, whoa, went quite down, huh? Experiments also. Woo! That was quite a lot which I used here. I used quite a lot, but this for testing, so almost 2 seconds I used what I have 95% remaining. So, and yeah, you see the experiments here. Tuck. Come on, it's a quantum computer, right? But it was executed in milliseconds. It just shows me here, probably because of the system which you use takes more time to display it. But if I don't show the verbosity, it's quite fast, right? It uses only milliseconds to process it. And this is already huge. If I would do that with my computer, it would take hours probably, yeah, or days only to do that. Maybe, yeah, because it's 2030 is a huge integer. Yeah. This is just a short thing. Yeah, it's not copied. D-Wave. Let's see what. Yeah, the D-Wave version. Let's see. D-Wave version. That's what I wanted. Haha, funny. Here we go. I'm using this version, the D-Wave Cloud client server version here, 0.5.4. And this is just a glimpse which I showed you here. The normal random problem would be just like, would look like this. D-Wave R. And let's go to the bigger screen, execution. Oh, I made a... Oh yeah, I need to write it. I think random problem R. What was the code again? I wrote that wrong here, I think. Chip ID. See? Using the D-Wave 2000Q quantum chip. And this is not a joke, I'm accessing it directly. No? With all the properties, the annealer, the offset range, the steps, the offset step, the annealing time range. The time range is set from 1 millisecond to 2000 milliseconds. So everything which is calculated, which actually took longer to calculate, it will be it will be abort, because if somebody may write something which take longer, that would be taking too much time, and it's already extremely fast. So what takes that long time must be an extreme program. Whichever you can achieve this for the moment, you can, of course, but you know, just to say. So in this version, the trial version I have, or actually in general to test. So every person who actually signed up for, or was able to, or is able to sign up for D-Wave Leap can access a quantum computer. So the time is limited here for the moment. It will not be limited. It will be extended for if you paying for it, of course. But for the moment, it's just what you have here. But you're accessing a real D-Wave quantum computer here, and this is awesome. If I would be the perfect programmer, I could write quantum computing code and send it to a quantum computer from D-Wave to execute it. So I can basically write my own quantum application. My own quantum application. This is if I would be the programmer, I would do it. If you're the real programmer, you're the wizard of tomorrow. You can do extreme stuff, and it is and will be extreme. Yeah, think about your programming neural networks on a quantum computer. It can be executed extremely fast, and yeah, think about what you can do with it. Opens up a new world, right? So I encourage everybody who can program, definitely look. This is the future of computing. This is the future, how we compute in the future. And it started 2018, 2019. This is called, we're entering the quantum age. Remember what I said, quantum age. And it will be extreme. And in the future we will have artificial intelligence, or so-called intelligent systems everywhere. In autonomous driving cars, in autonomous flying taxis or air vehicles, autonomous air vehicles, and so on, and then robots and all the kind of things. And Google said, it has nothing to do with D-Wave here at the moment, but Google said from their own research and development in the quantum computer area, it said it's short to supremacy, to what kind of supremacy? To artificial supremacy or something like this, right? So they are developing their own quantum chips, and we will have one day, I truly believe, super intelligence. So what you see in movies, what you saw in the movie, like, I don't make advertisement here, but like iRobot, or the newest, one of the newest movie which has to do with artificial intelligence. What was the name? Still something? Yeah, with a robot girl. Yeah. It will be one day. This will happen. So we will have super intelligent robots, and not that far in the future. Because D-Wave said, the CEO of D-Wave said in a clear statement, actually he said that publicly, one of his predictions is that by the year 2027 or 2027, as I remember, 2027, artificial intelligence will do almost, or actually everything what humans do, or humans can do, or actually humans do, let me say it this way. So that means, think about, that is how far away? 7-8 years from now. And we will, because Google is calculating, let me put that by side, it's getting a little bit brighter here. Google said that we will, actually Google is already, since about 10 years, Google has since about 10 years a D-Wave quantum computer, and is upgrading it upgraded it over the years. All the time with more qubits and faster calculation times. It was or is developing artificial intelligence on that quantum computer, and only using that quantum computer from D-Wave, always upgraded over about the last 10 years, only to develop artificial intelligence. Think about it. And I believe much more into the future, because the quantum computers are fundamentally or very different. For example, if you calculate or would like to calculate a problem on a normal classical supercomputer in today's time, it could take hundreds or thousands of years to finish. Even today, it could. If you use a quantum computer, it could be solved in an extremely short amount of time. Seconds, minutes, less hours, maybe a few days, who knows. But I think it will be much shorter than that. Some seconds, minutes, hours, something like this. Instead of maybe even much shorter than that. Who knows? Yeah, but they are extremely much faster. So it's a complete new way of calculation. So we don't wait what on the result to return, which probably will not return by classical supercomputers because it takes too much time. We can solve it in our lifetime, and I believe in a very short amount of time when we run it on quantum computers. And when then a so-called real big quantum computer is here, maybe they already have it, but when we have a real quantum computer, the potential of a real quantum computer or quantum computers, nobody really knows at the moment. So it is, I believe it's extreme from already what they said from their calculations. So we will solve problems, find new things which we could not do by even the best supercomputers existing today in 2019. Yeah. So everybody is looking at quantum computer and quantum computing, because this is it's a new era which just have started. Huh? Okay. This will be written in the book of history. Just to say. Okay. 2018, 2019 is the day to remember when it comes to quantum computing age, when almost everything really started to happen. Well, we already had good quantum computers 2016, 17, 18, but really now 2019 it really starts off. It really starts off. So. And why waiting for a result for many years, many weeks, or many months, or many years? I want to have this in seconds, right? How about you? Okay, you see the potential? Just, yeah. All right, this was just a short introduction. And yeah, the number of active qubits is already, which I can use by 2030. So you may go and put in Google qubit or qubits and then read about it. I have access to number of active qubits 2030. Okay, this is huge, but I know that D-Wave already have a quantum computer which has 5,000 plus, 5,500 plus or so qubits, or maybe even 10,000 already today. Who knows? It's getting bigger and bigger. This is like parallel universes you add with every quantum with every qubit, quantum bit. So this is real, huh? And it's publicly accessible, at least as I know I think it is in Canada and USA and Europe. At least I have it from Switzerland. From Switzerland! Yes, D-Wave ping. Let's see. D-Wave solver. Yeah, man. D-Wave solver. Yeah. I want to see the version. Yeah, I already did that. Okay, that was just a short introduction which I showed you, and I hope you like it. There's much more to be seen, to be done. I wish you all a great day, but before, please consider to subscribe to my channel for more. If you like it, also like, and of course share it to all your good friends. It would be, or it is, much appreciated. Thank you so much for your time, for listening, and I believe you have never seen something like this because it's just happening, it's just starting. And yes, this is real. I show you real stuff, real things. Thank you so much for your time, and wish you, let me say it this way for the moment, wherever you are, a good time and peace in, and talk to you in another video. Thank you so much.